Now, keep the textbook open. Okay. Okay. Now, how many groups do we have in the modern periodic table? 18. And how many periods? 7. 7 periods, correct? Horizontal rows are called periods. And vertical columns, they're columns. You see this column? It's vertical. These are columns. They are called groups. Okay? Now, okay. Now, pay attention. What is atomic size? Yes, but what is it? Tell me. I know. Dr. Nathan is another way of saying atomic size.
Center of the nucleus to the last shell.
Yeah, it is the distance between the nucleus and the last shell. Okay, orbital. The valency electron. A valency shell. Okay, that is the atomic size. Now pay attention. In the periodic table, you keep the periodic table page open. In the periodic table, okay, as you go, okay, from left to right, in a period. Now remember, or imagine the period to be a classroom. Now, when there is, say, this classroom consists of only one child, and picture the nucleus, then I have to teach this one child. I'm going to talk to you very softly. The interaction will be very normal. Only interaction. Then this video will be lesson. Same classroom. Means the second group, 2 electrons, the 2 valence electrons, 2 children. Then comes third group. Third group means in the same period. The classroom is the same. The third child is entering. Fourth idiotic child is entering. Fifth and all, and it kept on increasing. So do you think my voice will be giving that soft? As the number of children keep on increasing, in my classroom, my voice will keep on increasing. What are you getting? What? By increasing my voice. Why do you think? To make sure that the last child hears what I'm saying. I will say, she's only talking to him, or she's only talking to the board. We can't hear what she's saying. So I will keep on increasing my voice as the number of children enter the same period, enter the same classroom. Okay? By trying to increase my voice, actually what I'm trying to do, I'm trying to bring that last child under my control. I'm trying to bring that last child under my control. In other words, I'm trying to shrink the classroom. So in other words, as the number of children keep on increasing, my force of attraction will keep on increasing. I will try to attract her. Here, okay, you just looking at then she is coming. I'll try to attract her. I'll have to hold you. I'll try to hold you. I'll try to hold you under my grip. In other words, I'm trying to shrink the classroom and bring you closer to me. Okay? So, this is the general principle. So, in a periodic table, from left to right of the period, in the same period, the valency electrons keep on increasing or they keep on decreasing? Come on, valency electrons keep on increasing or they keep on decreasing in the same period? Don't open your mouth. They keep on increasing. So if they keep on increasing, nuclear force of attraction will keep on increasing. Correct? The controller will have to increase. So therefore, as you go across, remember my word, across, the preposition is across the period from left to right, as the number of electrons in the same shell keeps on increasing, nuclear force of attraction will keep on increasing. The teacher's disciplinary action or disciplinary strength will keep on increasing. Why? Because she's trying to strengthen the classroom. So atomic size will keep on decreasing. So, sodium, pay attention, look at my, finally take down and pluck the eyeballs, and play marbles with them. Because I'm not using them for the proper place, so I use them to play. Look at me! So for sodium, the atomic size is so large. Then, in the case of magnesium, 2 extra electrons have entered, so the nucleus is attracting it. Aluminium, 3 entered, and still holding. My force of attraction is increasing. As it comes to after aluminium will come 4 group. Carbon, 4 electrons. I'm shrinking. After carbon, it will come now. It comes to boron. After carbon will come, okay, we see then nitrogen. Okay, carbon is 4, nitrogen is 5. Again, as the number of electrons keep on increasing, nuclear force of attraction will keep on increasing, and the shell will keep on decreasing. So by the time it comes to the 7th group, the nucleus force of attraction is attracting 7 electrons and it has closed. So such a big atomic size has now become small. Now, when you go to the 8th group, this is already so small and there is no more place, and you are thrown it to put the 8th electron inside. 8th electron has to go inside, and because you put the 8th electron inside, there is electron force of repulsion. So much of the fighting is there that the large shell slightly opens up and is slightly bigger than the 7th shell. Slightly bigger. So, according to the normal trend, atomic size will keep on decreasing from left to right of the periodic table. In the same period, atomic size will keep on decreasing because as the number of electrons keep on increasing in the same classroom, nuclear force of attraction will keep on increasing. However, when you come to the 7th electron to be entered in the same shell, the shell has become so small, so tight, that it's difficult to put in one more electron. Still, you're putting another electron in, and then you put the other electron inside, the 8th electron inside. What happens is there's electron force of repulsion because the electrons are so close to each other that because of the repulsion, the 8th shell is slightly expands to accommodate that 8th electron. Hence, therefore, the 8th shell is slightly larger than the 7th shell. And all the shells are decreasing. This will slightly increase because it will accommodate 8 electrons and because of electron force of repulsion. But as you go down the group, this is across the period. Now this is down the group. when you go down the group, okay, one extra shell is entering, N is equal to 1 atomic shell. L has got 2 shells. M has got 3 shells. M is equal to 3 shells. KL and N has got 4 shells. So as you go down the group, the shells are increasing or not? Correct? It's like this way. As you go down the group, you are going from this classroom to another classroom, to another head from first standard, you go to the second standard, N is equal to 2, then you go to the third standard, N is equal to 3, then you go to the fourth standard, N is equal to 4. Are you not moving away from the nucleus? Yes or no? So when you're moving away from the nucleus, can the nucleus control children in the next classroom, and in the next classroom, and in the next classroom? No. So the orbitals keep on increasing, because the nuclear force of attraction is decreasing. So down the group, because the number of shells keep on increasing, nuclear force of attraction keeps on decreasing. New shells means new classroom. I can't control 9th standard and 10th and 11th and 12th at the same time. So those children are far away from me. And they can run away. Correct? So therefore, because the atomic shells are increasing, the distance is increasing from me, and my force of attraction, my force of control is lessening. So they'll be moving further and further away. The atomic size is increasing. Down the group, shells are increasing. Electrons will be one only. Correct? Shells are increasing. Across the period, electrons are increasing. Electrons increase means nuclear force of attraction increases. Shells increase means nuclear force of attraction is decreasing. Get that concept into your heads. Have you understood? So question will be asked to you. Show the trend in the atomic size across the period down the group. Down the group, atomic size keeps on. Now check. Down the group, atomic size keeps on. Down the group, atomic size keeps on. Huh? Down the group, this is the group, this is the period. Down the group, atomic size keeps on increasing or decreasing. Huh? Yeah. Right. Because? No. Electrons are one. In group 1, all the electrons are 1. And electrons don't increase. What increases down the group? What increases down the group?
Down the group of the values. The shells.
The shells keep on increasing. Classroom keeps on increasing. So therefore, atomic force of nuclear force of attraction is decreasing. So the shells will become bigger and bigger. Across the period, what increases?
The number of electrons.
Electrons increase. So therefore, what happens?
The
Atomic
number
size
of
increases.
classrooms and the number of electrons.
Don't use word classroom. Classroom
Sorry, the number of shells and the electrons, like both are increasing.
No, shells don't increase. They're already in the n is equal to 2. Say.
No, like it's 2,
3, 4, 5, 6. That is same shell, same classroom. Number of children are increasing. Children are increasing. Number of electrons are increasing. So what happens is the atomic size?
It also increases.
The atomic size
increases
across the period.
No, it remains the same.
That means nothing changed. All this, ever since I entered the class, half an hour, you've learned nothing. It by?
Because when the number of electrons increases, the nuclear force of attraction also increases.
Yeah, and so therefore the shell will decrease. Yeah. What about what we observe in between the 11th and between the 7th and the 8th shell?
7th shell has 7 valence electrons and 8th shell has 8 valence.
Yeah. So, what about the size of the size of the shell?
Size of the 8th shell becomes little smaller because of nuclear force of attraction.
Size of the little bit the size of the 8th shell
will decrease.
Decrease.
Because
Why?
the electrons are more. So the nuclear force of attraction will increase.
You.
Ma'am, from the group 1 to 7, it will keep on decreasing.
Yeah.
But in the eighth group, it will increase because
What
of
will increase?
the atomic size.
Yeah, by
Because electron, it cannot accommodate one more electron, and that is why it forms a repulsion between electrons.
you cannot explain properly. You cannot accommodate them.
It forms like a repulsion.
Yeah, it cannot accommodate the eighth one. Still, they are putting the eighth one in. And when you push the eighth one, there's electron force of repulsion, which creates a slight increase in the shell. So 8 is always greater than the 7. So normally it should be smaller. Okay? Now, you know fully well that when an electron is donated, the shell disappears. The shell disappears. And if the electron is accepted, it may be accepted in the same shell or a new shell is created. So, which atomic size is greater? The size of the atom or the size of the ion? Which size is greater? The cation is greater or the anion is greater? Why? Tell me. Which size is greater? Anyone tell me? Tell me. Huh? What is the anion?
It accepts.
That's a negative. It is negative.
Yeah.
So what happens to that cell?
It accepts.
So then
So the shells increase.
the cell increases.
Number of shells.
Yeah. And the cation,
It gives.
it gives
So
out.
it is.
Yeah. So the cation, the atomic size is smaller than the corresponding anion. So if sodium has gone and donated one electron to chlorine, sodium ion shell decreases because it lost one electron. Chlorine accepted that one electron, so it became chlorine ion, it became chloride ion. So chloride ion shell is bigger than the sodium ion shell. So remember, the chloride ion accepts electrons. So chloride ion or all anion shells are larger than the atom. Chloride ion shell will be larger than chlorine atom shell. Yes or no? Chloride ion shell, it became a chloride ion. How? It accepted an electron. To accept the electron, to accommodate the electron, the size has to become big, isn't it? So chloride ion shell is bigger than chlorine atom. Yes or no? And sodium ion shell is smaller than sodium atom shell. Because sodium atom lost the electron and it became an ion. Because it lost electron, its shell became smaller. It lost. So that's what it became. So the cation shell is smaller than the corresponding atom, positive atom. And the anion shell is larger than the corresponding atom. Okay? Remember that. Then, now, let us talk about metallic character. Now, what about metallic character? In the metallic character, how does a metal become positive? How does it become metallic? It donates an electron. When you donate an electron, you become metallic. So, from left to right, the metallic character increases or decreases? Decreases. Sodium gives out one electron. So it's strongly metallic. Magnesium is giving out 2 electrons. It's becoming less metallic. Aluminum is giving out 3 electrons. It's becoming still less electric. As the number of electrons keep on increasing, the metallic character will keep on decreasing. And it becomes decreasing till it comes to carbon. Carbon is absolutely non-metallic. Correct? Its valency is 4. After that, they are accepting electrons or not. After carbon, electrons have been accepted. They're all non-metallic. So when they're accepting electrons, they are becoming non-metallic. 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 Highly non-metallic is argon. Is this clear?
Right?
Argon.
Argon is open, yes.
Yeah.
Argon is
Of course, gases are non-metallic. Gases are all non-metallic. What do you say?
but how is argon non-metallic? It should be inert. It does not excite.
It's a gas now, you idiot. It may be inactive, but its physical properties are there, no? It's a gas. It's non-metallic. It may be inactive, but it is non-metallic. What is wrong with you? Can you not understand this? If you're inactive and you're not doing any work, it doesn't mean you cease to be a boy or what? Your physical properties disappear? True. If you're sitting quietly in the classroom, not doing any work, inactive, your physical properties disappear? You remain a boy, no? Yes or no? Then it is inactive, but its properties are still there. It is non-metallic. What's your problem? What was the difficulty?
I thought argon was inert, so it would not be non-metallic.
Non-metallic is not a chemical property, it's a physical property. It's a physical property. Follow? You are a boy, it's not a chemical property, it's a physical property. Whether you're active or inactive, that's a different story. But you will remain, physically, you will remain the boy. So, this is the thing. So, if you go from left to right, okay, you are metals, don't say metals. Elements are losing electrons. They're donating electrons. Because they are donating electrons, they're becoming metallic. The number of electrons will tell you how strongly metallic they are. Sodium gives out 1 electron, very strongly metallic. And it gives it out very fast. Magnesium is giving how many electrons? 2. It's becoming slightly weak. Aluminium is giving out 3 electrons. It's still becoming weaker. Carbon is not accepting, nor is it donating. It is sharing. So it is becoming now non-metallic. After carbon comes what? Then comes nitrogen. Nitrogen is accepting electrons or donating electrons. It's accepting. Because it's accepting, it's becoming non-metallic. It's becoming non-metallic. So it accepts how many electrons? It accepts how many electrons? Nitrogen accepts how many electrons? 3. So it is weakly non-metallic. After nitrogen comes halogen, oxygen. Oxygen is accepting how many electrons? 2. It's becoming a strongly non-metallic. After that comes what? Halogens. It's accepting 1 electron, strongly non-metallic. And argon is accepting nothing. It's very, very strongly non-metallic. Near. Inert gas, near. So in the case of metals, the more the electrons they donate, the weaker is their metallic character. While in the case of non-metals, the less electrons they accept, the more non-metallic they become. They become less metallic or strongly non-metallic. Opposite, their properties will be opposite. Now, how do we call or we name these groups? Okay, we have we know fully well that the the metals are referred to as first group. It's called alkali metals. Second group is called alkaline earth metals. Okay. Then comes boron family, aluminum boron family. Then comes after aluminum comes carbon family. After carbon family comes nitrogen family. After nitrogen family comes oxygen family. After oxygen family comes halogen family. After halogen family comes inert gas or zero. This is the way we will name it. This is the way we will name it. Okay, first is alkali metals. Why they call alkali metals? Because these metals, when they combine with oxygen, they form oxide. Sodium will combine with oxygen to give you sodium oxide. When you take that oxide and dissolve in water, it will give you sodium hydroxide. That hydroxide is a base. It's a base and it is water soluble. Water soluble bases are called alkalis. That you all know. Water soluble bases are called alkalis. So they form alkalis, strong alkalis. So that's why it's called the alkaline family. Next group is called alkaline earth family. Why earth family? Because those alkalis are heavier, earthy, they're heavier. They also, those metals, when they combine with oxygen, give you metal oxide. When those metal oxides are dissolved in water, they give you metal hydroxide. Those hydroxides are water soluble bases. So they are called alkalis, but they are heavier. So they are called alkali earth metals. Correct? So that is how we do. Then finally we come to oxygen family, nitrogen family, oxygen family, that is the same thing. We come to halogens. Now what are halogens? Halogens, halo means salt. Gene means formation. They form salts. Their binary compound HCl, HCl, HBr, then HF. Okay, these are all halogen compounds, binary, meaning having two elements H and F, H and Cl, H and Br, and these are salt formations. Okay, they form salt, very active, highly reactive. So that is your general study of the periodic table. Now remember with your periodic table, your valency keeps on increasing. One group, one valency, second group, second valency, third group, third valency, fourth group, fourth valency. After fourth group, the valency keeps on decreasing. How? After 4 it should be 5, isn't it? The valency becomes 3. Then it becomes 2, it decreases. Then it becomes 1, it becomes 0. So from 1 to 4 it increases. From 4 to 8 it will decrease. That's the way the periodic trends in the periodic table. The valency keeps on increasing from 1 to 4 and decreases from 5 to 8. From group 5 to 8, the valency decreases. That's all. I want to see further than this. I will just wait till there. Next time when I come, I will. Okay. Number of shells. Number of shells. Do they increase down the group or across the period? Number of shells. Number of shells. Down the group, do they increase or they increase across the period? Down the group. Across the period, what increases? Across the period, what increases? Shells increases, balance increases, what increases? Shells increase across the group. What increases across the group? Number of electrons, number of valence electrons. Alright. I will read to them. Study of specific groups, I will teach you next time. Study of specific groups, I will teach you next time. Okay? Grab it. Read. Did you understand what I explained to you this time, or I found it too boring and too heavy? You can answer my questions for me. Read. you read, start answering all the questions from the lab and university up to where I've taught you. The last part of it I'll teach you next time and start with hydrogen after next time. That's on Friday, next Tuesday. Today got Tuesday, then I have a Friday. Friday again. I should present the portion and give you your school start, the whole 9 7 portion will be over. Then it will work. I hope so. Then I don't have to see your faces, or I don't have to see my face the rest of the day. Or you're having 6 hours per week. 3 today, 3 on Friday, every week, Tuesday, Friday, Monday to English Friday. Then I finish up the portion. Fast. Pardon me? I don't care if they just sleep there also, who cares? I have a teacher there.
Chemistry.
I talk about chemistry in Polish school. You don't get idiot. I talk about my chemistry. Huh? Gada. Calling you a gada and insulting the poor donkey, you know that? Poor donkey. He has done nothing for me, to me. Such a useful animal it is.
By the time our second semester, third semester exam comes, we forget all this.
Then you have to ask for revision classes. Then you have to ask for revision classes. We'll forget, definitely I will forget. Because chemistry is not an easy, it's not a subject where you have to, you can retain it for long. You have to keep in touch with it all the time. Keep in touch with it all the time. That right now, you learned and understood right now. Quick, start writing now. Work out your work. You don't want to do. Huh? You don't learn the question answer also? Where's the volume? Yeah. Work it out. You do the volume. Hmm. And you have to ask her, ask them how they went about it. For water, but for which part of it now? He part only. Then you can come and join them. That's the problem. You don't have to ask her. Just come. Just come. You come online. You're coming to class on Sunday. Then they're sitting on here and doing it here.
Online.
Online. You come and sit here with them. No?
What time?
11:30.
Even my pay participate.
11:30. 11:30 to 12:30. Because right at 11:05 you're having a test. No? So I told her to put it at 11:30. So she said, okay.
Are you there for this? Yeah.
Here, by 11:15 you be here. 11:30 I'll start the class. I'm at home. Come here. You might have to rest. Pack up and go home then. Don't waste time. Or sleep at this point. What he's doing, he's sleeping. You also sleep. Don't worry. Don't disturb her. Why disturbing him? You want to go to sleep, you sleep. What are you doing? Are you writing or not? Huh? You're not into like by heart, you have to come here to look. Are you learning it? While you're okay, are you learning it or you're just reading? You had an older sister in North Point School many years ago, who also learned from beauty classes. When you went there,
You're sharing this with us.
you're sharing the book or you're sharing your gossip? Book. How much have you written down that you shared the book?
And this book is fun.
You have to start next year. Now you go to sleep like him. Start next year. Why are you bothering to do all the work now? Go to sleep.
You don't care. You don't care.
Please.
You don't care.
He
doesn't care.
He doesn't care.
Speaking wrong English, wrong.
The subject is
chemistry.
English
Chemistry right now.
English
Chemistry right now.
But I teach, listen, I teach in chemistry, in English. Not in Hindi, not in Marathi, not in Gujarati, not in Dakar English.
Proper.
Yes.
English. Where is not agree with the sentences according to we agrees with the
Subject, verb, activity.
Come on, hurry up. Your English teachers also speak English in school, no? Your English teachers also speak English in school, no? Or they speak in another language?
No,
English. Speak.
Electron sharing means like the financial or total number.
When they talk about electron shell, they mean the valence shell. It's a valence shell, yeah.
Will it affect you in any way? But I don't know. I trust you. Additional questions.
नहीं स्कूल में सब वो करते हैं ये
You do that with your left hand.
Yeah.
You could do on your left hand, right hand.
I'm a left. But I can write with right hand as well.
You hear it, you write with left hand, no, right, right.
No, I didn't. But still, I can write with right. But the handwriting is
There, there.
right. Right.
General trend, the number of shells and valence electrons. Number of shells increases automatically and number of valence electrons. As a shell, if it is C, first shell, what is your number of electrons? 1. Second shell, 2. Like that. It will increase. The valence electrons equal to number of groups to which the element belongs. Also, number of electrons in a given element is equal to number of periods to which it belongs. That means that also number of electron shells in a given element equal to number of periods. If the period is say for instance 3, then what happens if the period is divided to 3? Okay, then the number of shells is 3. Correct? So listen to me like this. I'll tell you one thing. Suppose it is like this. Yeah. Suppose you have got an electronic configuration like this. Pay attention. You have an electronic configuration like this. 2, 8, 2, 8, 2, 12. Suppose you've got 12. Okay? You've got electronic configuration 2, 8, and 2. Pay attention here. Pay attention here. If you have got, post it on there, that's it. If you have an electronic configuration, this is magnesium, correct? 282, right? This last 2 will tell you valency electrons. Correct? It tells you valency electrons. It also tells you valency. It also tells you valency. If 2 is the valency, okay, then you know whether it's metal or non-metal. You know whether it's metal or non-metal. So whether it is metal, okay, then you also know whether it is getting oxidized or reduced. So this is getting oxidized, and it is a reducing agent.
Reducing agent getting oxidized.
Understood? See the properties you have got from this information. Now, if this is 1, 2, and 3, if it is this 3, this means third period. This is first energy level, this is second energy level, this is third energy level. Yes or no? So that means this is the third period. So this electronic configuration will tell you so much of information you will get when you do the electronic configurations correctly. So you come to know whether it's valency, you come to know whether it's metal or non-metal. Okay, you come to know whether it's cation. Okay. Then you also come to know that its shell is less than the metal. Shell is less than the actual metal because it is lost to electrons here. Okay. All this information you get from the electronic configuration. The number here, 1, 2, 3 means tells you the period or the energy level. First the energy level, this is K, L, M. Third. Okay? All this information. Did you follow? All of you followed? Yeah? Okay, go now. So I wanted to tell you next time. Wrap it up. Fine. Still half an hour to go.
Yes, when you घर में तो क्या बोलते हैं जो चौकी लेके तो क्लास कर रहा है मेरे पूछ रहा हूँ वहाँ पे है करना क्या है या और ला के दिखो उसके लिए नहीं वो बोल रहा है कि और है उधर किसी को ना दे मैं तो और लेके आके दिखाऊँ नहीं मैं बस
Now, there is a question. Moving left to right in the second period, the number of atoms select.
What happened?
Moving left to right in the second period, the number of atoms select.
What happened to valence electrons? Keeps on increasing from 1 to 4 and from 5 onwards decreases. Again the same. Now pay attention like this. See what happens is in the case of as you go across the period, the chemical activity of the elements keep on increasing. Okay, remember, chemical reactivity depends upon the donation or acception of electrons. Now, in the say third period of sodium, magnesium, then you got aluminium, and you've got sulfur, phosphorus, and so on. Okay? Then what happens is sodium has got how many electrons in the outermost shell? 1. Aluminium has got how many electrons in the outermost shell? 3. Correct? Yet, now, sodium has only 1 electron in the outermost shell. Aluminium has got 3 electrons in the outermost shell. Yet, aluminium is less reactive than sodium. So chemically reactivity keeps on decreasing from left to right in the periodic table. Right.
Even the valence is increasing.
So then, the value increases means the chemical activity increase, no? See, pay attention. The shell is becoming smaller and smaller and smaller. When the shell is so big, it's like an open tin. It's easy to give the electron out. But in the case of aluminium, the shell is closed. And you have to take out how many? 3 electrons. Correct? So the difficulty increases. So the shell has become small. Hence, therefore, chemical reactivity keeps on decreasing. It's the same, it's a simple thing like this. Chemical reactivity does not depend upon the number of electrons you have. It depends upon how fast you give away those electrons. I'll explain to you. Suppose you are a very poor person. Suppose. And I am a very, very rich person. Only suppose. In spite of the fact that you are poor, yet you have kept your door wide open and you told everybody, please come and enjoy whatever you have. The little that I have, enjoy. My door is wide open, you're welcome. Everybody is welcome. I'm poor, I don't have much. But whatever it is we have, we'll enjoy ourselves. And I've got lots, but I've shut my doors. Me, myself, whatever I have is for myself and for myself only. I have got lots, you've got very little. Who's more reactive? You are. You. So it does not depend upon how much you have. It depends how fast you give it and how you interact with people or you interact with other elements. Sodium is only 1 and the house is wide open and that 1 it gives to everybody. Aluminium has got 3 but its house is shut. So it's difficult to take out anything from this house. I may have lots, but I'm giving nothing. So I will not be so reactive as usual. Hello? What am I shaking your head like that?
I'm saying this.
Huh?
Keeps on saying.
What is that? What are you saying?
He said yes, he's recording, convey the message of saying yes.
Okay. You're his mouthpiece, or what? Huh? You're his mouthpiece?
Nice.
Hey, what are you doing now? Both of you? Everyone is thrashing? But you wanted it not, I'll give it to you. Because you're not doing what I'm expecting you to do. Come on, hurry up, don't waste time.
I'm friendly with me. I don't talk to her every day, still she don't talk to me. Mama knows that we don't talk to her every day, but we're still friends. Yeah, I watched it when
Ma'am, that day you got the picture. I don't know. What were you finding that day?
That day I wanted to find out Nalanda.
yeah, but
You got.
No, she's out of Bombay.
yeah, I don't know what she's saying.
Yeah.
But
She's out of Bombay.
discharge
That's a good family, but girl who got my child, no.
Yeah.
I wanted to go in, jail. So, she said that they're out of Bombay.
And they're going to do that now.
How can I go?
I think they're coming up on 26.
Where are they gone?
Japan.
Oh, my grandmother was gone.
Sorry.
But her father is gone. Her father is gone.
Oh, father is still in the ship.
Yeah, it's a mother and a woman.
I want to have like daughters,
And the grandmother.
grandmother and daughter.
The two daughters, no.
Yeah, even her daughter who lives in the right.
I tell you, that is one is John. John and Debbie. She used to come down. And their son, Rajesh. Husband's name is Rajesh. What is the boy's name? Darren. Darren, yeah. He must have been quite big.
Yeah, how does he home was he was 20s.
I am the one and you have to be.
No, I think
for alternative numbers 3.
Yes, we have seen the end. Basically.
I guess I should keep it. Now my
We remember it.
maybe. Actually, same kind of question.
This is a sound of it. You hear something that's not this one is basically working for the food. All the components of the food, this is paper and research. As to this meaning. I don't think she was saying Next.
Wait for the next question. Wait for the next question.
What? Or वो real baby What? Real baby.
Commando black, commando black.
Ew.
Butter chicken at that
European Union.
commando black.
अरे मेरा छोटी छोटी
5 मिनट
कहाँ जाना है? नहीं कहीं बाहर मैं जाने से काट
वो ना वो
मैं वापस नहीं आ रही भाई तुम लोग इधर ही
हाँ बेचारे
ले
no
और एंड कर